Hello everyone. 1 minute. Hello everyone. Good afternoon to all guys. So today we are going to discuss some previous year questions of the chapter limit, right? So let's start. Okay. So already you have studied what is limit, all things, all you have solved many solved lot of problems in limit also. You know? So let's start some previous year questions which have been came in your JEE mains previously. So we'll discuss those questions in this session, right? So let's start. So first of all, we have some series expansions, right? So Rahul sir taught you also, है ना? So actually some important expansion. So sin x का expansion, tan x expansion of tan x, expansion of a raised to x, expansion of 1 plus x to the power n, expansion of ln of 1 plus x, and expansion of sin inverse x. Likewise, here many expansions are given in your screen. You can take a screenshot of this screen and you can keep it with you, right? So it will be helpful in when you will solve some questions, है ना? ठीक है? So this series will be helping in problem solving. So let's take a screenshot of this page, right? Okay. So let's move to the first question. So what is the first question we have here? We have here in the question it is given, you have to evaluate the limit extending to 0 sine of pi cos square x upon x square. So what is the limit of this function, right? So this question came in 2001. Okay. Let's solve this question. So what is the solution? Let's discuss. Okay. So it is given that limit extending to 0 sine of pi cos square x, right? So I write sine of pi minus pi sine square x? Can I write this? Yes, we can write now because we know cos square x is 1 minus sine square x. So क्या हो जाएगा मेरा pi minus pi sine square x we can write, or we can write this as also simply we can say sine of pi minus x is sine x. So we can write sine of pi minus pi cos square x is okay. So let's solve likewise. Okay, pi cos square x. Let's solve this way in this way. pi अगर मैं इसको ऐसे लिखूं साइन ऑफ पाई माइनस पाई cos square x, right? ठीक है, this is sine of pi minus x is sine of x, right? So we can write this as so simply what we will do, okay, if I'll take common pi from the bracket, so what will happen? Sine of pi into 1 minus cos square x, yes or no, है ना, whole divided by x square, yes or no? So can I write now limit extending to 0 sine of pi 1 minus cos square x is sine square x, right? Sine of pi sine square x upon x square, right? Understood or not? ये सबको समझ में आ रहा है ना? ठीक है, चलो तो now think what will do now. अभी हम क्या कर सकते हैं एक्चुअली? है ना. So if I'll multiply pi sin square x and divide with pi sin square x, so what will happen? Let's see. Limit extending to 0 sine of pi sin square x, sine of pi sin square x upon x square into, मैं क्या किया ना, साइन ऑफ पाई साइन स्क्वायर एक्स, ठीक है, पाई साइन स्क्वायर एक्स मल्टीप्लाई किया एंड ऑल्सो डिवाइड पाई साइन स्क्वायर एक्स, ठीक है. सो कैन आई राइट दिस आज दिस वे? लेट्स सी. हम उसको ऐसे लिख सकते हैं क्या? इफ आई रीअरेंज दिस फंक्शन, लिमिट एक्सटेंडिंग टू 0 साइन ऑफ पाई साइन स्क्वायर एक्स divided by pi sin square x, okay, into pi into sin square x divided by x square. Can I write this? है ना. And we know limit extending to 0 sin of x divided by x gives you 1. ये तो मुझे पता है, ठीक है ना. तो similarly we can write here limit extending to 0 sin of pi sin square x divided by pi sin square x into limit extending to 0 pi into sine of x upon x का whole square. Can I write this way? Yes or no? है ना. So if you'll put the limit here, अगर हम यहाँ पे लिमिट पुट करें तो ये जो ग्रीन वाला पार्ट है ना, मैं जो ग्रीन वाला पार्ट को मैं बोल सकता हूँ क्या, दिस इज बिकम्स 1. एंड ऑल्सो लिमिट ऑफ साइन एक्स अपॉन एक्स गिव्स यू 1, तो उसका स्क्वायर क्या हो जाएगा, दिस ऑल्सो गिव्स यू 1. सो क्या मिलेगा मुझे, व्हाट इज द लिमिट हियर, फाइनली आई एम गेटिंग 1 into pi into 1, that is your answer will be pi. Is it clear guys? है ना. So what is the answer of this question? Pi. So what is the correct option? Correct option is option B, right? Option B is your correct answer, right? है ना. So I hope this question or this solution is understood to all of you guys. If you have any doubt, you can ask in the chat box, guys. I'm waiting for you for 10 seconds. If you have any doubts, you can ask me. Yes. Any doubt you can ask. YouTube guys, I'm here. You can write your doubts in the chat box. No doubts? Okay. So let's move to the next question. Okay. So, okay. So for this question, this is your second question. Let's wait. Yes, this is your second question. Okay. And this question came in 2019 JEE mains. Okay. 2019 JEE mains ka question. So I am giving you for this question, I'm giving you 2 minutes. Let's try these questions. Try these questions and try to get the answer within 2 minutes. And your time starts now. You can start now. You can solve these questions. First, when you are solving questions of limit, you must check whether the function is in which form, where in which form the function is. Okay, you have to must check this one. Okay, it's a very easy question. Within three to four lines, we can get the answer. Okay, try this one. Any one of you got the answer? Please write in the chat box. Any one of you got the answer? Please write in the chat box. Okay. I already told you, before solving the questions you must check the form of the function. Okay, any one of you got the answer? You can message your answer in the chat box. Okay, so it's time to start. Okay, so let's discuss the solution of this question. Okay, guys. Okay, so what is given in the question? Limit extending to 1 x raised to 4, limit extending to 1 x raised to 4 minus 1 divided by x minus 1, which is equal to limit extending to k x cube minus k cube divided by x square minus k square. ठीक है, ठीक है. So then you have to find if if both the limits are equal, then find the value of k, right? Then find the value of k, or we can say for which values of k these both the limits will be same. Okay, value of both the limits will be same. So let's discuss solution. So we know, I already told you to check what is the form when we are putting the limit, what is the form you are getting in this question. Okay, so in the first limit we can check here, when we are putting x is 1 extending to 1, so 1 minus 1 numerator becomes 0 and denominator also becomes 0, right? So it is in the form of 0 upon g. Okay, and come to the right hand side. In the right hand side also, when you are putting x is k, so k cube minus k cube is 0 and k square minus k square is 0. So this is also in the form of 0 upon g, right? So then we can simply here we can put the L'Hopital rule. What is that rule? L'Hopital rule. So what is the L'Hopital rule? So we have to differentiate the numerator with respect to ix and also differentiate the denominator with respect to x. So let's start. Limit extending to 1 x square x to the power 4, derivative of x to the power 4 is 4x cube minus 1 का 0, right? And नीचे क्या आ जाएगा? That is 1. Okay, differentiation of x is 1. Similarly, here in the right hand side also we are getting limit extending to k 3x square minus k cube, that is 0. Derivative of k cube is constant, so derivative of k cube is 0. Come to the denominator, what we were getting? 2x, right? So in the right hand side, what we are getting? We are in the right hand side, we are getting x to cancel ho jayega. That is limit extending to k 3x upon 2, right? 3x upon 2. So now try to put the limit here. If we'll put the limit, so what we are getting actually, let's see. So if you'll put extending to 1 in the left hand side, what you are getting? 4, which is equal to, and in the right hand side, if you will put the limit extending to k, so what you are getting? 3 upon 2 k, right? So here k is equal to, I'm getting, that is 8 upon 3. So answer is 8 upon 3. Within 3 steps, we are getting the answer, right? So for k is equal to 8 upon 3, both the limits will be same. So what is the correct answer? Option D is your correct answer. So 8 upon 3 is your limit, value of k, right? Okay. Chalo. Let's move to the next question here. Okay. Okay. See here, the integer n for which limit extending to 0 cos of x minus 1 cos of x minus e raised to x divided by x raised to n. Okay. Then is a finite non-zero number is. So I'm giving you 1 minute for these questions. You can solve it. I'm giving you 1 minute for this question. Okay. And your time starts now. You can solve it. Try to solve this one. Here you must use the series expansion of cos x e raised to x, right? Already in the first page, I gave you all the series expansion of cos x, e raised to x, sin x, and all these things I have already told you. And use those series expansion here and try to find the limit. ओके ठीक है anyone of you got the answer can you tell me what is the answer you got guys okay ठीक है चलो so let's discuss the solution here see your solution is like this है ना we know what is the given in the what is given in the question ये दिया था मुझे limit extending to 0 cos of x minus 1 into cos of x minus e raised to x whole divided by x raised to n है ना so after this step मतलब this is your question है ना and I suggested to you to use the series expansion of cos x and e raised to x right so we know cos x minus 1 so 1 minus cos x is actually what is 1 minus cos x we know this from the trigonometric formula half angle formula we can use your 2 sine square x by 2 right 2 sine square x by 2 so cos x minus 1 क्या हो जाएगा if you'll if I'll ask cos x minus if 1 minus cos x is 2 sine square x by 2 so cos x minus 1 क्या हो जाएगा cos x minus 1 is actually minus 2 sine square x by 2 ठीक है clear okay so in place of cos x minus 1 I have written here minus 2 sine square x by 2 and we know series expansion of cos x 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial up to so on and similarly we know the series expansion of e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on right ठीक है and in the denominator we have x raised to n right ठीक है so now if we'll subtract this from this series to this series है ना तो क्या मिलेगा मुझे 1 minus 1 gives you 0 1 1 cancel हो जाएगा ठीक है then minus x minus 2 into x square by 2 factorial so here we have x square by 2 factorial twice है ना so then if I'll subtract minus x square by 2 factorial minus 2x square by 2 factorial so what you will get 2 into x square by 2 factorial है ना similarly minus x cube by 3 factorial है ना and then minus twice of x to the power 4 by 4 factorial so basically we are getting this series basically we are getting this series when we are subtracting this series of e raised to x from series of cos x we are getting this series right ठीक है now see so what now you are getting if you try to write the denominator x raised to n in the form of 4 into so x raised to n को क्या मैं लिख सकता हूं ऐसे 4 into x by 2 का स्क्वायर ठीक है into x raised to n minus 2 okay why I am writing this है ना because here in the argument of sin x we have x by 2 so if we'll take x by 2 in the denominator then we can simplify the limit easily right yes or no so that's why I'm trying to write x raised to n in the form of 4 into x upon 2 का whole square that is denominator 4 cancel हो जाएगा x square into x raised to n minus 1 always again gives you x raised to n so I have written here x raised to n is in the form in this form okay now tell me okay after writing this way what you are getting let's see sine square of limit extending to 0 sine square of x by 2 upon x by 2 का स्क्वायर इज 1 ये लिमिट तो मेरा 1 हो जाएगा दैट मींस ये जो है था this function gives you 1 and after then what you are having we are having limit extending to 0 1 plus x square by 2 factorial and so on whole divided by 2 into x raised to n minus 3 okay so क्वेश्चन में ये दिया है कि लिमिट मस्ट बी फाइनाइट है ना so this limit to be finite क्या करना चाहिए, देन n-3 must be equal to 0, है ना. If n-3 becomes 0, then this limit becomes x tending to 0, 1 plus x square by 2 and so on, whole divided by 2. Now, if the denominator, now if you will put x tending to 0 here, so what you will get? All the terms becomes 0 except 1. So 1 upon 2 you will get. So here we are getting a finite value. So when n-3 becomes 0, then we are getting a finite limit. Okay, so if n-3 is equal to 0, then what is the value of n? N is equal to 3. N is equal to 3. So this is the answer. This is the answer actually. So for n is equal to 3, for n is equal to 3, this limit gives you a finite non-zero number. So this is the correct answer. Option C is your correct answer. Is it understood, guys? Is it clear to all, guys? Everyone, let's reply in the chat box. Is it clear to all, guys? Is it clear to all? Everyone, please reply in the chat box, guys. I hope this is clear to all of you guys. Let's move to the next question. What we did in this question, just we are using here the series expansion of cos x and e raised to x. Then after we can simplify it and we can easily evaluate the limit, right? Okay. So let's discuss the next question. Let's come to the next question. What is the next question? Here in the question given that for each x belongs to 1, for all real values of x, and this denotes the greatest integer of x, right? Greatest integer less than or equal to x. That is the definition of greatest integer function, right? And you have to find the left hand limit when extending to 0. Limit extending to 0 minus, okay, 0 minus x into greatest integer of x plus mod of x whole into sine of greatest integer of x upon mod of x. Is it looking? It is looking like a very completed question and a complicated question. It's like here we have used modulus, greatest integer functions, trigonometric functions. So many functions are using in this limit, right? So we must know what is we must define before going through the question. Before going through the solution, we should know what is greatest integer of x, what is mod x, and what is if we greatest integer function of x present in sine of x, sine argument of sine, then what we should do. So this is the thing. So easily we can evaluate this limit. No need to be worried. So कैसे कर सकते हैं हम उसको? देखो. So let's discuss the solution of this question. Okay. So question में ये दिया है limit extending to 0 minus x into greatest integer of x plus mod of x whole into sine of box of x divided by mod of x, right? Here we have 0 minus, right? 0 minus, ठीक है? So 0 minus means, देखो, if we'll simplify this function, so what we are getting here, limit extending to 0 minus, right? So x into greatest integer of x plus 0 minus means it's a negative number. It's a negative number, right? So mod of any negative number is positive of x, है ना? So that is ये क्या हो जाएगा? x minus mod box of x minus x होगा कि plus x होगा? When 0 tending to 0 minus x tending to 0 minus, तो we know modulus function का जो definition होता है, that is when x is greater than or equal to 0, then mod x is x, and when x is less than 0, then mod x gives you minus x. Understood? है ना? So this is actually gives you minus of x into sine of greatest integer of x. That is here also we can write minus of x. Understood or not? Is it clear? Okay. Now we'll apply the greatest integer when extending to 0 minus. What will be greatest integer of x? So when x is less than 0, right? Or we can say when x is tending to 0 minus. That means ये क्या हो जाएगा मेरा greatest integer of x gives you -1, because we know box of minus 0 point something, suppose 5 है ना, ये क्या दे रहा है तुम्हें, -1 दे रहा है ना, सो ये क्या हो जाएगा ना, सॉल्यूशन विल बी, कैसे हो जाएगा सॉल्यूशन, व्हाट इज द सॉल्यूशन, इज इक्वल टू लिमिट एक्सटेंडिंग टू 0 माइनस एक्स इंटू, ये क्या हो जाएगा, -1 माइनस ऑफ एक्स साइन ऑफ -1 डिवाइडेड बाय -x, ठीक है, इज इट क्लियर, ओके, चलो, so now let's try to simplify this question. If you'll simplify it, what we are getting here, limit extending to 0 minus, okay, limit extending to 0 minus, so if we'll take -1 as common, तो ये क्या हो जाएगा, -x into 1 plus x into sine of -1 divided by -x. So now we can see, we can cancel out -x from denominator and numerator also. Okay. So what we are getting here after cancelling, what you are getting here? So let's see. We are getting limit extending to 0 minus 1 plus x into sine of -1. Okay. So if you put the limit, what you are getting? 1 into sine of -1. So answer will be sine of -1. So this is your answer. है ना? Sine of -1 is the correct answer. ठीक है? Sine of -1, which is equal to, also we can write minus of sine 1. है ना? Minus of sine 1, because we know sine of minus theta is equal to minus of sine theta. ठीक है ना? ठीक है, so answer is minus of sine 1. ठीक है, so what is the correct option? Minus of sine. Option C is the correct. Option C is your correct option. ठीक है, I hope this is clear to all of you guys. Any doubt you can ask. If you have any doubt you can ask. Simply, देखो कुछ नहीं किया हूं मैं. Just we have used here the concept of modulus function and also the concept of greatest integer function. Nothing else. है ना? It's very easy question. है ना? 2019 JEE mains में आया हुआ question है ना? This question came in 2019 JEE main. ठीक है, very recent year questions है ना? So limit एक ऐसा चैप्टर है ना, limit is a topic which question you can solve in entrance exams, right? So you must study this topic or chapter very carefully, है ना? You must thorough in this chapter, ठीक है? So let's move to the next question. What is the next question here? Oh. See here also we have modulus function, greatest integer function, all these things, है ना? ठीक है, so क्या दिया है मुझे? You have to evaluate the limit when extending to 1 plus, right? Extending to 1 plus में तुम्हें ये लिमिट को इवैल्यूएट करना है, and for this question also you have 2 minutes for this question. Let's try this question to solve. Your time starts now. You can start. You can start solving. Guys, same concept use होगा, just you have to simplify. ठीक है, like the previous question we can solve this question also, so try to solve this. So 20 seconds more. Let's see who is getting the answer first. Okay, it's time. How many of you got the answer? Can you write your answer in the chat box? Can you write? Yeah. Anyone? ठीक है, ठीक ठीक. So let's discuss the question. Okay. Solution. Okay. So in the previous questions, we did found the left hand limit, or we have found what is the left hand limit when extending to 0 minus, right? So but in this case we'll find the right hand limit when extending to 1 plus, right? Extending to 1 plus. So let's discuss the solution. So in the question, what is given? Limit extending to 1 plus, right? 1 minus mod of x plus sine of 1 minus x mod of 1 minus x whole into sine of pi by 2 greatest integer of 1 minus x, right? Okay, whole divided by mod of 1 minus x into greatest integer of 1 minus x. ठीक है? Okay, so let's discuss. Okay, so for this question, how we can solve this question actually? Let's think how we can solve. Simply, what we'll do, है ना? If I'll ask, if you'll put, let x is equal to 1 plus x, and we know x is tending to 1 plus, then if x is tending to 1 plus, h is tending to 0 plus. Again, if x is tending to 1 plus, so h will tending to 0 plus. So we'll try to find the limit when h is tending to 0 plus, right? ठीक है, so चलो निकाल के देखते हैं, है ना? So suppose I'm writing x is tending, sorry, h is tending to 0 plus, right? So 1 minus x, 1 minus mod of x, right? 1 minus mod of x. Can we write in place of x? Can we write what? If x is equal to 1 plus h, so we should write na in place of mod of x. We can write 1 plus x, mod of 1 plus x, right? Plus sine of 1 minus x is minus x, है ना? So sine of mod of minus x. Can we write? है ना? Because we know ना 1 minus x is 1 minus x is x, है ना? 1 minus x is minus x, है ना? So here I'm writing this way, and sine of pi by 2 into, in place of 1 minus x, can we write 1 minus x is minus x, है ना? So minus x, greatest integer of minus x, whole divided by, okay, mod of minus x and greatest integer of minus x. ठीक है, clear? Okay, now see, now what we'll do, क्या करना चाहिए हमें, देखो. So mod of 1 plus h gives you when x is, when mod of 1 plus h क्या हो जाएगा, h is a positive quantity and also 1 is a positive quantity, है ना? So 1 plus h is greater than 0. That means ये हो जाएगा मेरा limit h tending to 0 plus 1 minus 1, that is 0. तो ये हो जाएगा मेरा 1 minus 1, 0 हो गया, ये हो जाएगा minus of h plus sine of h, because mod of minus is h, sine of h whole into sine of pi by 2 into greatest integer of minus h, right? And ये क्या मिलेगा मुझे, h, है ना? mod of minus h is h into greatest integer of minus of h, right? है ना? ठीक है, चलो, तो ये तो मेरा हो गया, है ना। ओके, नाउ ट्राई टू सिंप्लीफाई फर्दर। अगर फिर से हम सिंप्लीफाई करें तो क्या हो जाएगा ये? तो ये हो जाएगा, सही है ना। चलो, सो वी नो व्हेन एज टेंडिंग टू जीरो प्लस, तो माइनस, ये क्या हो जाएगा? ग्रेटेस्ट डेंजर ऑफ माइनस एज टेंडिंग टू जीरो प्लस को जा रहा था ना, व्हेन एज टेंडिंग टू जीरो प्लस, तो माइनस ग्रेटेस्ट डेंजर ऑफ माइनस एज टेंडिंग टू -1, बिकॉज ये एक पॉजिटिव क्वांटिटी है। सपोज आई एम टेकिंग 0.2, है ना। सो माइनस ऑफ 0.2 का बॉक्स क्या हो जाएगा? ग्रेटेस्ट डेंजर क्या हो जाएगा? -1। तो दिस टेंडिंग टू -1, राइट। तो ये अगर -1 हो गया, तो नाउ लेट्स सब्स्टिट्यूट एच टेंडिंग टू जीरो प्लस माइनस एच प्लस साइन ऑफ एच होल इंटू साइन ऑफ π/2 इंटू -1। ये तो हो गया ना -1, दिस टेंडिंग टू -1 हो रहा है, तो माइनस ऑफ π/2 एच इंटू -1, ठीक है, ये हो जाएगा -1। ओके, तो ये हो गया क्या? सिंप्लीफाई करने से मुझे मिला एच टेंडिंग टू जीरो प्लस माइनस एच डिवाइडेड बाई -h प्लस साइन ऑफ h divided by -h. So we can simply write here minus of sin h upon h, right, into sin of -π/2. Is it clear? यहां तक सबको समझ में आ गया ना? क्लियर है ना? अंडरस्टूड गाइस? सिंपल। ओके, so let's now solve. Now, oh, now this gives you 1. So limit h tending to 0 plus 1 minus sin of h upon h into sin of -π/2, right? Sin of -π/2. तो ये हो जाएगा, if you put the limit or if you simplify this, can we write this way? Limit h tending to 0 plus 1 minus limit h tending to 0 plus sin h upon h into limit h tending to 0 plus of sin of -π/2, ठीक है, हम ऐसे लिख सकते हैं ना। ओके, so this gives you 1 minus this gives you also 1 into तो ये 1 minus 1, okay, this is this, here you have a bracket also, नहीं? So ये हो जाएगा मेरा क्या? 1 minus 1, that is 0 into, गलत तो हो गया कुछ। ओके, सो हम ऐसे कर सकते हैं ना उसको, चलो डायरेक्ट मल्टीप्लाई कर देते हैं, उसके बाद लिमिट होगा, ठीक है। तो लिमिट एक्सटेंडिंग टू 0 प्लस, ये हो जाएगा 1, 1 minus 1 0। ओके, if you multiply this sin of -π/2 minus sin of sorry, limit of limit minus limit extending to 0 plus sin of h upon h into sin of -π/2, राइट। तो ये हो जाएगा मेरा क्या? माइनस साइन ऑफ π/2, साइन ऑफ -π/2 इज साइन ऑफ माइनस साइन ऑफ π/2 एंड साइन ऑफ π/2 इज 1, तो ये हो गया मेरा -1 माइनस ये हो जाएगा तो मेरा 1, इसका तो लिमिट 1 हो जाएगा ना, ये लिमिट 1 हो जाएगा, एंड ये साइन ऑफ -π/2 इज -π/2, साइन माइनस ऑफ साइन π/2 दैट इज -1 आल्सो। ओके, तो 0 हो रहा है क्या लिमिट? यस, वी आर गेटिंग 0, है ना। 1 minus 1 plus 1, that is 0, है ना। So answer is actually 0 here, right? I think or I hope this is clear to all of you guys. Let's see the answer. What is the answer here? 0. The limit is 0. Limit gives you the answer is 0. Huh? Okay. So what we did in this question, just we have used here the concept of greatest measure function and also the modulus function, है ना। ऐसे कर करके हमें क्या मिल गया? The value of this given limit is 0, right? ठीक है. I hope this is clear to all of you guys. If you have any doubt, you can ask in the chat box. If you have any doubt, you can ask in the chat box. Everyone, quickly. Sure. Okay, clear? Sure. So let's move to the next question. Yeah, wow. Here you have a question. If limit extending to 0 of 1 plus x log of 1 plus b square whole to the power 1 by x is equal to given is equal to 2b sine square theta, and when b is greater than 0 and theta belongs to minus pi to pi, when minus pi is excluded and pi is included, then you have to find the value of theta, right? You have to find the value of theta. क्या कर सकते हैं? पहले तो before solving the question, before evaluating the limit, you must check what is the form the function is in. Okay, कौन सी फॉर्म में मेरा फंक्शन का फॉर्म है ना, है लिमिट. आफ्टर पुटिंग द लिमिट, what is the form you are getting, so then we can evaluate the limit. So let's check whether the question which the given question in which form. Okay, so limit extending to 0, if you put 0, 1 plus 0, ये हो जाएगा 0, 1 to the power infinity है ना. So the form of this question is 1 to the power infinity, and we know when we have the function is in the form of 1 to the power infinity, so what is the formula you should use? ये बताया था ना, limit extending to 0 f of x raised to g of x, right? Limit extending to 0 f of x g of x, if it is in the form of 1 to the power infinity, that the limit will be e raised to, आंसर क्या हो जाएगा ना, e raised to limit extending to 0 f of x minus 1 into g of x. So this is the formula, है ना. अगर ये जो क्वेश्चन गिवन क्वेश्चन 1 to the power infinity के फॉर्म में होगा, then the limit of the given question will be e raised to limit extending to 0 f of x minus 1 whole into g of x. Here, chalo. So let's discuss the solution here. Okay, so we know the given question in the form of 1 to the power infinity, so let's use the formula here, है ना. So this will be e raised to what is, which is f of x. F of x is, I'm taking here f of x as 1 plus 1 limit extending to 0 1 plus x log of 1 plus b square minus of 1 f of x minus 1 into g of x, and g of x is 1 upon x, right? So what you are getting, limit extending to 0 1 तो कैंसिल हो गया, अरे वाह. तो ये लिमिट एक्सटेंडिंग टू 0 x log of 1 plus b square into 1 upon x. अरे again x is also cancel out, है ना. तो what you are getting, limit e raised to limit extending to 0 log of 1 plus b square, right? And we know so after putting the limit, what you are getting, e to the power log of 1 plus b square, right? Log of e raised to 1 plus e raised to log of 1 plus b square, है ना. तो ये मेरा क्या हो जाएगा, by using the properties of logarithmic, simply can we write this 1 plus b square, this can we write this as 1 plus b square, ठीक है. So suppose this is question, okay, so here we are getting the limit as 1 plus b square, okay, and it is given as it is given that this 1 plus b square is equal to 2b sine square theta, right? 2b sine square theta. So let's solve. 1 plus b square is equal to 2b sine square theta. And from here we are getting sine square theta is equal to 1 plus b square whole divided by 2b, है ना, whole divided by 2b. Okay, so now we'll use the concept of arithmetic progression mean and geometric mean, and we know always arithmetic mean is greater than equal to geometric mean, right? Always we know कि arithmetic mean is greater than equal to geometric mean, right? ठीक है. Okay, so what is, if we'll consider two numbers, one is b, another is 1 by b, है ना. So agar if you'll consider these two numbers b and 1 upon b, so what is the arithmetic mean of these two numbers? So concept use करो, am is greater than equal to cm, right? तो arithmetic mean क्या हो जाएगा ना, b plus 1 upon b divided by 2, and geometric mean will be b into 1 upon b 4 to the power 1 by 2, right? So this gives you, this inequality gives you b square plus 1 divided by 2b is greater than equal to, pb तो cancel हो गया भाई 1, है ना? So b square plus 1 upon 2b gives you greater than equal to 1, right? So this is greater than equal to 1, and we here we got sine square theta is equal to 1 plus b square upon 2b, है ना? So this is equal to also sine square theta. So here I am getting sine square theta. Sine square theta is actually b square plus 1 divided by 2b, है ना? ये already पता है मुझे. And but from here in equation 2 we are getting this is greater than equal to 2, and in equation 1 we are getting sine square theta is equal to b square plus 1 by 2b. Okay, समझ में आ रहा है सबको? So that means the only possible value from, by considering the equation 1, by considering 1 and 2, what we are observing here or what we are getting the conclusion, we are getting the sine square theta जो होगा that must be equal to 1, क्योंकि only the possible value of sine square theta is 1, because we can't take sine square theta gives you greater than 1. Sine square theta can't gives you greater than 1 value, right? So sine square theta must be equal to 1. तो थीटा क्या हो जाएगा बेटा ना, साइन थीटा हो गया 1, एंड थीटा क्या हो जाएगा ना, थीटा इज इक्वल टू प्लस और माइनस pi by 2, right? If sine square theta is equal to 1, then theta we are getting plus or minus 1 by 2, right? What you are getting 1 by 2, sorry, ये नहीं, साइन स्क्वायर थीटा अगर तुम्हारा 1 है तो थीटा क्या हो जाएगा, प्लस और माइनस पाई बाई 2, एंड बोथ माइनस पाई बाई 2, minus pi by 2 and plus pi by 2 both are lying between the given interval, that is minus pi excluded, my pi included, है ना? So थीटा क्या हो जाएगा ना, थीटा हो गया मेरा प्लस और माइनस पाई बाई 2. So what is the answer here? The correct answer is plus or minus pi by 2. Option D is the, है ना? So option D is the correct answer. Is it clear to all of you guys? I hope this is clear to all of you, because it's a very easy question. So, we have used here three concept here. First one is जो one, when the limit is in the form of 1 to the infinity, 1 to the power infinity, what is the formula? That is e raised to limit extending to 0 f of x minus 1 into g of x. After applying this, you must use the properties of logarithmic and solve and evaluate the limit. Then use the concept of arithmetic mean and geometric mean. So after getting arithmetic mean and geometric mean, you can reach here. B plus 1 upon 2b is greater than equal to 1. And another relation you already got, that is sine square theta is equal to 1 plus b square upon 2b, right? So sine square theta is equal to 1. So theta क्या हो जाएगा, plus or minus 1, right? Plus or minus 1, sorry, plus or minus pi by 2, है ना? So theta हो गया मेरा plus or minus pi by 2, right? Okay. So let's move to the next question. Okay. So here you have a question. Chalo. And for these questions you have 1 minute. Try to solve it. The time starts now. Anyone of you got the answer? Anyone of you? Okay. So it's time. Okay, तुम्हारा ठीक है. So anyone of you got the answer? You can write the answer in the chat box. You can write your answer in the chat box. Anyone? Okay. ठीक है, लेट्स डिस्कस द सॉल्यूशन. ओके, सो इन द क्वेश्चन आंसर इज 0. आंसर इज 0. ठीक है. सो limit extending to pi by 2 tan square of x of 2 sin square x plus 4 sin x plus 3 whole to the power 1 by 2 minus sin square x plus 6 sin x plus 2 whole to the power 1 by 2. So first right is in it is in the root over form, है ना. So this is actually on root of this and on root of this and try to rationalize, है ना. सो अगर हम रेशनलाइज कर लेते हैं तो क्या मिलेगा मुझे ना. इन द न्यूमरेटर आई एम गेटिंग sin x minus 1 का होल स्क्वायर अपन cot x, right. Sin x minus 1 का whole square upon cot x. And if we will use the L'Hopital rule because this is in the form of 0 by 0 by 0 form, right. Here 0 by 0 form में मुझे मिल रहा because when we'll put sin of pi by 2, sin of pi by 2 gives you 1. So 1 minus 1 is gives you 0. So 0 cot pi by 2 is also 1, 0. Now, so 0 by 0. So after getting 0 by 0 form, what you are getting, that is using the L'Hopital rule. Use here, use the L'Hopital rule. ठीक है. L'Hopital rule के यूज करेंगे तो इफ यू डिफरेंशिएट द न्यूमरेटर, है ना. अगर हम डिफरेंशिएट करते हैं तो क्या मिलेगा मुझे 2 sin of x minus 1 into, देखो यहाँ पे हम यूज करेंगे. ओके, एंड साइन यहाँ पे लिमिट पुट कर देंगे तो मुझे क्या मिलेगा. दिस इज 2 sin square pi by 2 is 1. So 2 plus 4 plus 2 plus 4 plus 3 is 9. So on root of 9 gives you 3. This also on root of 9 gives you 3. So 3 plus 3, ये वैल्यू 3 दे रहा है, ये भी वैल्यू 3 दे रहा है. तो 3 plus 3 is 6. So 1/6 को मैं बाहर ले लिया, है ना. 1/6 को मैं बाहर ले लिया and tan square x को I have written here 1/cot square x. So finally what you are getting, 1/6 limit extending to pi by 2 1/6 sin square sin x minus 1 का होल स्क्वायर sin x minus 1 का होल स्क्वायर डिवाइडेड बाय cot square x. ठीक है. उसको by using the L'Hopital rule मुझे क्या मिलेगा, that is limit extending to pi by 2 1/6 into differentiation of numerator, that is 2 into sin of x minus 1 into sin differentiation of sin x is cos x, right, whole divided by 2 cot x and differentiation of cot x is minus cos x square x. ठीक है, minus cos x square x. And if we'll simplify this now, मुझे क्या मिलेगा, that is limit extending to pi by 2 1/6 into or 2 into sin of x minus 1 into cos x divided by 2 into 2 तो कैंसिल हो जाएगा ना. cot x को I am writing here cos x upon sin x and 2 minus 1 upon sin square x. cos x square x is minus 1 upon sin square x ना. so cos x भी कैंसिल हो जाएंगे. तो मुझे क्या मिला अभी, that is limit extending to pi by 2 1/6 into sin x minus 1 divided by 1 upon sin cube x, right. So sin cube x, that is limit extending to pi by 2 minus 1/6 into sin of x minus 1 into sin cube x, right. So this gives you, when you will put x tending to pi by 2, if you will put the limit here, what you are getting, that is minus 1/6 1 minus 1, that is 0 into 1, that is 0, है ना. so ये हो गया मेरा 0. तो टोटल आंसर इज 0. so आंसर इज 0, है ना. बहुत ही इजी क्वेश्चन है. that is answer is 0. answer is 0. I hope this is clear to all of you guys. Everyone clear of this question, of this solution? Everyone, can you write in the chat box, guys? Everyone, please write in the chat box. Okay. ठीक. So let's move to the next question. Here it's a very easy question. Try to solve it. What is the answer? है ना. Limit extending to 0 x of cot of 4x upon sin square x into cot square 2x, है ना. So इसको हम सिंपली कैसे कर सकते हैं ना, लिमिट एक्सटेंडिंग टू 0 x x और x को हम ऐसे कर सकते हैं ना, x अपन cot 4x कैन बी रिटन एज 1 अपन tan 4x, तो x अपन tan 4x into 1 अपन sin square x into 1 अपन cot square can be written as tan square x 2x, है ना, tan square 2x. So what we are getting here, that is limit extending to 0 x tan square for 2x divided by tan of 4x into sin square x, right? Tan of 4x into sin square x. Tan of 4x into sin square x we are getting, right? Okay, now. ठीक है, so limit extending to 0, if we'll write 4x divided by tan 4x. So we have multiplied here 4 with the numerator, then we have to divide also with 4, into tan square of 2x. Okay, let's see, 4x into 1 upon क्या था मेरे पास, सही है. So what we'll do now, we have sin square x here. So what we'll do, x square, here I'm multiplying x square and dividing with also x square, ठीक है. So x square, okay, तो क्या मिला मुझे, 1 upon x square into tan square of 2x, right? ठीक है, तो इसको फिर से हम सिंप्लीफाई करने के लिए क्या कर सकते हैं, tan square of 2x. So if we will multiply 4 and divide with 4, है ना, so what we are getting here, देखो मैं सिंप्लीफाई कर दिया, अभी लिख रहा हूँ, ठीक है. So limit extending to 0 4x upon tan of 4x. Okay, so this 4 will be cancelled out. Limit extending to 0 into a limit extending to 0 x square upon sin square x. Okay, and into limit extending to 0 tan of 2x, and this is 4x square, that is we can write 2x the whole square, है ना. So simply you can observe here, this limit becomes 1, this limit becomes 1, this limit becomes 1, right? So 1 into 1 into 1. So what is the answer you are getting? Simply 1 I am getting the answer, right? What is the answer? 1 is your correct answer, है ना. ठीक है, है ना, easy, है ना, it's an easy question, right? है ना, an interesting question also, है ना. Just you have to rearrange the function to bring the functions, given function is in the standard limits, right? हम स्टैंडर्ड लिमिट का फॉर्मूला यूज करके आराम से इस टाइप का क्वेश्चन को कर सकते हैं, ठीक है. ओके, सो दिस इज ए होमवर्क फॉर यू. लेट्स ट्राई दिस क्वेश्चन टू नेक्स्ट क्लास. ओके, ट्राई दिस क्वेश्चन इज इन योर होम, ना, we'll discuss in the next class this question. Okay, so thank you all of you guys. That's all for today's session, है ना. We have solved some previous year questions of limit chapter, है ना, and in the next class we'll discuss the homework, and I hope Rahul sir will continue your class, right? Because Rahul sir is in leave today, so I have taken your class. So thank you guys, all of you. Thank you. Bye. Take care.